Hi, I'm Charlie Sitler. I teach mathematics at the Beekman School, and I'm glad to be able to talk to you about geometry and algebra and all things mathematical. There's a famous formula for the square of a binomial, parentheses a plus b squared equals a squared plus 2ab plus b squared. We're going to take that as a given, and we're going to run with that formula to show how a simple geometric interpretation can turn that into a demonstration of the Pythagorean Theorem, probably the most important theorem in all of mathematics. Okay, so we have this famous formula for the square of a binomial. A plus b squared is equal to a squared plus 2ab plus b squared. It's algebraic, but it's also geometric in its import. We have a square here with each side length a plus b. I've made a considerably longer than b so you can keep track. A plus b, a plus b, a plus b, a plus b. The area of this square must be a squared plus 2ab plus b squared. Let's see what else we can get it to be. All right? We're going to draw segments with connecting these notches here where a morphs over into b. And we're going to produce a jigsaw puzzle with 5 pieces in it that's all going to add up to our original big square. So the area, however we determine it now, must be equal to a squared plus 2ab plus b squared. Let's see what we can do. We've got 4 right triangles. Right triangles because a square has right angles. A, B, length A, length B, length A, length B, length A, length B. So we're going to use the traditional letter C for the hypotenuse of right triangles. So we have 4 right triangles with legs A and B, and the hypotenuse of each is C. They're all congruent, and we can establish that they're congruent by leg, leg, or side, angle, side, any number of ways to get triangles congruent. And that means that the length of the hypotenuse is going to be equal in each one, and this figure here in the center is going to be at least a rhombus with all 4 sides congruent. Let's take a look at this jigsaw puzzle. We got 5 pieces in all. The first 3 are right triangles. Area. Famously, the area for any triangle is 1/2 base times height. But special for right triangles, you can take either leg to be the base, and then the other leg becomes the height or the altitude drawn to that base. So the area for triangle 1 is going to be 1/2 AB. Same for 2, 3, and 4. We have 4 of these guys. 4 times 1/2 AB gives us a total area for the 4 triangles of 2AB. Now, let's see what we can do with this big piece in the middle. Jigsaw puzzle piece 5 is at least a rhombus. All sides are congruent. If we can get that this is a right angle here in the corner, it's not just a rhombus, it's also a rectangle, and the 2 combined give you a square. I think we can do that. We have congruent right triangles. Here's the right angle of one of them, and these are the 2 acute angles of the right triangle. By a theorem in first semester geometry, the 2 acute angles of a right triangle are complementary, add up to 90. Now this angle is congruent to this angle. So we have 3 angles here in all that make this straight line, or straight angle if you like, 180 degrees. These 2 add up to 90. This angle here must be 90 in itself, and we have what we want. Jigsaw puzzle piece 5 is both a rectangle and a rhombus, therefore it's a square. It's a square with side C. It has area C squared. And this whole square, the big one, has an area of 2AB for the 4 right triangles and C squared for the square. Well, here's what we got. A squared plus 2AB plus B squared from the algebraic formula must also, because of the way we cut it up here, equal 2AB plus C squared. You can almost taste it, huh? We take 2AB away from each side, and lo and behold, we have the famous formula A squared plus B squared equals C squared, the Pythagorean Theorem. Listen, this is Charlie Sitler. I teach math at the Beekman School. Thank you for your time and your attention. I look forward to seeing you again. And until then, you be well. Ciao.